My name is Michael Bailey. I'm a principal engineer working on Android at American Express. You can find me on Twitter at YogurtEarl, and today I'm going to talk to you about how Espresso works. So Espresso is part of the Android Test Support Library, and they just released the Android Test Support Library 1.0, and Espresso 3.0 is actually part of Android Test Support Library 1.0. So today I'm going to be discussing Android 3.0. Most of the source code is available at that link there, which is a link to maven.google.com. You can get it from the sources jar. This talk does assume some Espresso knowledge because we're going to be diving deep into the source code of Espresso. So especially if you're watching this online, you might want to pause this, go write your first Espresso test, and then maybe come back and watch this. And then it'll make a little more sense. So the source code that I have here is taken from Espresso 3.0. I have edited it to fit on the slides and also really emphasize the points of the source code that I'm going to be talking about today. All right. So this is a basic assertion in Espresso. What this is doing, and it kind of reads like a sentence, it's saying on the view with this ID, and this is the ID Bible search, this is an ID that may be in your layout XML, check that it matches is displayed. So you're basically saying assert that this view is displayed to the user. So let's break that down a little bit. These are the different calls that go into that simple statement. The first thing that gets called is with ID, and then the result of with ID will get passed into onView. When onView returns, it's going to call check, but before it calls check, it has to call isDisplayed. It'll take the result of that, passes into matches, and pass the result into check. So we're going to walk through each of these in more detail. So let's start with ID. It's a static import that comes from the ViewMatchers class, which is part of Espresso. It takes an ID, which is a resource ID, generally something attached to a button like you see here. We have the Bible search button that's attached to that in your layout XML. So we're saying that we want the view with that ID. So what does the with ID method do? With ID takes that integer and it's going to return a matcher of view. So matcher is not an Espresso API. It comes from a library called Hamcrest. So let's take a brief detour to look at what matcher is. Matcher is a very simple interface. You can give it an object and it will return true or false, whether it matches or does not match. Then it also has a method that allows you to describe why it didn't match. And this is very useful for logging and debug output. So you can say, give information and context about why it didn't match so you can see what was missing from your test. And this is from Espresso relies on Hamcrest 1.3 as part of the Espresso API. Matches is kind of the key logic method that you're going to have in a matcher. So in with ID, we take the ID, which is an integer, we wrap it in the is method, which comes from Hamcrest, and the is method just takes an integer and it returns a matcher of integer. So now we have a matcher of integer that's just looking for that integer, and we pass that into an overloaded version of with ID that takes the matcher of integer. And then that takes that matcher of integer, it wraps it in a with ID matcher, which is a class that is part of Espresso. It's internal to Espresso, and it is a class that implements type safe matcher, which is a convenience implementation of matcher that Hamcrest gives you, and it uses generics to give you a type safe method. So in this case, it's a matcher of view, so we get a method that takes a view instead of the generic object, which you would have to check as an instance of and then do a cast. So in this case, you just get the view. And this is a very simple matcher. All it does is it takes that view ID matcher, which wraps that integer, and it calls matches on that, and it calls view.getID to get the view that we're inspecting to see if they match, and it just calls matches, which ultimately just does a simple integer comparison. Now, you can see that you can implement your own matchers. This with ID is something that Espresso provides. It's very simple. But if you're looking for a specific view and you want to find, which view other than the ID that you're looking for in your view hierarchy, you can implement a custom matcher with logic in here that looks at every ID that's passed into it or every view that's passed into it one by one and says, yep, this matches, this doesn't match. Now, if you're designing a matcher for Espresso, it's important that in the success case, when it does match, or when the matcher is successful, that it either matches none of the views in the hierarchy or it matches exactly one view in the hierarchy. If it matches more than one view in the hierarchy, you run into a number of problems with the way you use matchers in Espresso. So you should design it to match one view in the hierarchy. Even with ID, sometimes if you have a recycler view or something like that, and you inflate the same layout, you may have multiple views in the hierarchy with the same ID. So you have to be mindful of that. All right. So we take the result of with ID, which is a matcher of view, and we pass that into the onView method. The onView method is a static method on Espresso. And so let's take a look at what the onView method does. The first thing it does is it calls sync. And what the sync is doing is it's taking one list of idling resources, which we'll talk about in a second, and just copying it to the internals of Espresso. So in Espresso 3.0, there's a new API called IdlingResource. And IdlingResource is part of a idling resources dependency. It's idling registry is the new API. Idling resource was already there. And it's in the idling resources dependency, which is a very small dependency that you can include in your app so that you don't have to include all of Espresso in your app, which you wouldn't want. And you can use idling registry to just add your idling resources right from your app. But then Espresso needs that list of idling resources that you've added in its internal implementation, which is the idling resource registry, which is an internal API. So essentially what it's doing here is it's getting the list that you gave it in the lightweight Maven artifact dependency, and it's just syncing that into its internal registry of idling resources. So once it's done that sync and that copy, so it has all your latest idling resources, then it goes off and it looks in its Dagger module. So Espresso internally uses Dagger 2, and specifically it has one base component that is used throughout the app, and then it uses subcomponents off of that. So it has one instance of this base layer component, and in this case it calls plus, which is kind of mimicking what you might have seen in like Dagger 1, but it's actually creating a Dagger 2 subcomponent. And it adds a new module which wraps your view matcher. So now it knows specifically about the views that you are looking for with your matcher. And now that it has that subcomponent, it can call view interaction, which provides an instance of view interaction. So how does Dagger get that instance of view interaction? It calls the injectable constructor. And Dagger uses its dependency graph to provide all the implementations of the thing that a view interaction needs. I've annotated here where what it actually resolves to when Dagger puts together all its modules. You get a singleton instance of UI controller impl as for the interface UI controller. You get an instance, every time you call onView, it creates a new instance of the viewfinder because the viewfinder actually wraps that view matcher that was passed into the module. You get a main thread executor, you get a failure handler that comes from a failure holder that's part of the component. You get the view matcher that you passed in, a few atomic references that it uses to track state, and then you get a remote interaction object that comes from the remote interaction registry. So every time you call onView, you get one of these view interaction objects wrapping your view matcher. And that is what's returned from onView. Now, we've got the little warning symbol up here because this is something I've seen in tests, and this line will always succeed. It kind of reads like it might actually check something, onView with ID, Bible search matches is displayed, but it's actually not, it's always going to succeed whether the view is there or the view is not there. And this is because it's passing a matcher into onView, and it's doing nothing with the result of onView. So as we saw, all onView does is create a view interaction object. doesn't actually do anything. It doesn't check anything. It doesn't perform anything. So this returns a view interaction object that is immediately eligible for garbage collection, and it just goes on to the next line. So this is always just going to pass right through in your test. So it's important when you call onView to always make sure you're calling .check afterwards, which actually does the work, or .perform if you want to perform the work. So this is just a watch out. If you see this in code reviews or otherwise, the test will pass. It's just not actually checking anything. All right, so the next thing that gets called is displayed, matches is displayed, but we're going to look at check first, and we'll come back to what matches is displayed does. So let's take a look at check. Up until this point, all this code has been executing on the test thread. Well, in order to inspect your view hierarchy or interact with your view hierarchy, you need to be on the main thread. So the first thing that check does is it takes this callable and it passes into run synchronously on the UI thread. So this jumps us over to the main thread and basically pauses the test thread until this can complete. So that's why it's called synchronously. So now that we're on the UI thread, we can call UI controller, if you remember that was passed in the constructor of view interaction. We can call that loop main thread until idle. And we're going to dig into what this means. For more context on the main thread and the inner workings and how loopers work and all that, I gave a talk at droidCon NYC 2015 on how the main thread works. So you can watch that one for more context on the inner workings of the main thread. All right. So first thing it does is it makes sure that you are on the main thread, because you shouldn't be calling this method unless you're already on the main thread. And then what it does, it's going to go through a number of different areas and see if they're idle. Basically, idle meaning they're not doing anything. The app is stable. It's just sitting there waiting for Espresso to act on it. So the first thing it does is it has an idle notifier called async idle. And async idle is a wrapper around the executor thread for your async tasks. So Espresso knows about all of your async tasks and if they're busy at the moment. And so this returns true if there's nothing going on the async task thread, or returns false if there's an async task currently executing. So if it's false, it's going to add async tasks to a list of, or a set of condition checks that it needs to later check for. The next thing is dynamic idle, which is also an idle notifier, but it's a wrapper around your whole list of idling resources. So when it calls dynamic idle, is idle now, it's checking through all of your defined idling resources to see if any of them are all of them are idle, or at least one of them is not idle. And then it'll return, it'll say, nope, they're not idle now, if even one of them is not idle. And so if they're not idle, then it needs to wait for that condition to be true. So it adds dynamic tasks have idled to the list of conditions it needs to check for. And it's called dynamic tasks have idled. It probably should be called like idling resources have idled, because it's kind of the same thing. And this comes from that, remember we saw the sync at the beginning where it syncs all your idling resources into idling resource registry. This dynamic idle notifier is a wrapper around those that comes out of idling resource registry. So in case you haven't implemented an idling resource, we'll take a brief detour just to remind you what an idling resource in Espresso is. So this is a public API. It's part of the Espresso API. It's an interface. And when you need to wrap some part of your application that is either busy or idle, you can wrap it in this, and Espresso will use this to determine, oh, the app is busy, I need to wait, and Espresso will just wait till your app is done doing whatever it's doing, or everything's idle, I can actually go and try to click that button or look at the view hierarchy and check for whatever views I'm looking for. So if you have network activity, if you've got RxJava activity, if you've got some other custom code that's keeping your app busy and you need Espresso to just hold off until that's done, you wrap that in an idling resource, you register that idling resource with Espresso, and then Espresso knows that it needs to wait for that. So the idling resource has two jobs when you implement it. One, it needs to respond to calls to is idle now. So that's Espresso asking the idling resource, hey, are you idle? And if you're not idle, then you're busy. And And so it says yes or no. But then, conversely, it needs to actually actively tell Espresso when it goes from being busy to idle. And it needs to call this callback called onTransition to idle every time it goes idle. So if you have something that's busy and it's idle, it's busy and it's idle, every time it goes idle, it has to call onTransition to idle. Now, if you have problems in your tests where you think like Espresso was trying to click the button, but the button wasn't quite there yet, or it was just checking that the text viewed on the screen, but the text wasn't quite there yet, it was coming over the network or whatever, you might be tempted to put a sleep in there, but sleep is probably not the right choice. You actually want an idling resource. Sleep is almost never the right choice in Espresso tests. And one of the main disadvantages of sleep is sleep never gets faster with Espresso speedups, if they speed up Espresso, or if you run it on faster hardware. If you put a 2-second sleep, 2 seconds is 2 seconds, even on the fastest hardware. Whereas if you use an idling resource, faster versions of Espresso, faster hardware can run your tests faster. So your tests will get faster over time. Whereas if you put sleeps in your tests, they're going to be slow forever. All right. So back into this method that we were looking at. So it builds a list of conditions that it needs to look at. It goes through, is it idle? Okay, it's not idle yet, so I need to basically loop until it's idle, and then adds those to that. So then it takes that list of conditions or set of conditions, and it passes that into loop until. So it's going to loop until these conditions are satisfied. Well, let's look at what that does. So loop until uses a thing called main thread interrogation. And main thread interrogation is actually an implementation of an interrogation handler. And we'll see handler on the next slide. But it's kind of a confusing name because the interrogation handler is a totally different concept than the handlers that are part of loopers and main threads and that. So it's kind of handlers meaning totally different things here. But essentially what main thread interrogation is it's an encapsulation of the logic around those conditions, that set of conditions we just built. And as we're going through the main thread, we send a series of events to the main thread interrogation, and it tells me, do I still need to keep iterating and looping over the main thread, or am I done? I'm not interested in looping anymore. So that logic is contained within the main thread interrogation. So we take that interrogation, we pass it into a method called loop and interrogate. So let's see what that does. So it does a number of different checks as it goes through the main thread message by message. First thing it does is it'll take the head message, the next message that's ready to be processed on the main thread, and it says, when is that ready to be processed? Because some messages can be delayed, you can set a delay on a message that's coming up on the main queue. So by default, the look ahead millis is 15 milliseconds, so it's looking to see if there's anything ready to be processed in the next 15 milliseconds. And if it is, it sends an event to this handler saying, hey, there's a task ready to be processed soon. And then the handler says, I'm still interested, keep going. Or it says, no, I'm not interested, that's good, you can stop looping the main thread. Or it'll tell you, hey, there's not a task due for a long time. And again, it gets a result, still interested. So if it's still interested, it goes down into this loop. And this logic, these couple lines right here are kind of the core magic, if you want to call it, that makes Espresso work. This is the kind of the key logic that makes Espresso both fast and reliable. And what this is doing, if you think about it, remember we jumped onto the main thread with that run synchronously on UI thread, so we're on the main thread. But this is using reflection to go and get messages that are behind it, waiting to be processed on the main thread, grab those messages, and then it calls dispatch message, which is basically execute the message. So it's on the main thread, stopping the main thread, but then it's reaching behind it and grabbing reflectively every message one at a time and saying, I'm going to process this message, I'm going to process this message. And this is all wrapped in a big while loop that says, am I still interested, am I still interested? And it's that handler looking at all these conditions. So every time we process a message, the handler is saying, okay, we need to keep going, our conditions haven't been met, our conditions haven't been met. It also, in this case, it says, okay, before I dispatch this task, it's sending a message to the handler and seeing if it's still interested. This gives the chance for the handler to have logic about, I need to time out. You've been trying to look at this main thread for 5 seconds, and obviously nothing's going to happen, or 30 seconds, and it says, I'm not interested anymore. So basically, it ends with a timeout. And you can see it returns the status of the handler, so you can see why the handler said it's not interested in processing any more messages. So that returns a result, and the result is one of three things. Either you got interrupted, somebody's interrupted your thread, and you're just going to throw an exception because you couldn't loop until the conditions were met. So you're just done at that point. Or you call the idle policy and you say, handle this timeout. Usually that will fail your test when it times out. Or it completed successfully. In that case, this method can just return. It looped the main thread, the conditions were met, it can just return. All right, so I have a little animation here to kind of give you an idea of what's happening with the main thread and the test thread, which are kind of coordinating in this case. So if you look here, the main thread's processing one message at a time as they come into the queue. Eventually your test starts, gets to a check, which adds Espresso and jumps over to the main thread. Eventually Espresso gets to the front of your main thread and it's grabbing the messages that are behind it and executing those messages one by one. And then once it's done, it jumps back to the test thread and continues on your test. And so every time you do a check or a .perform, this is the dance that Espresso is doing. And this is how it's able to immediately, as soon as the main thread is ready and everything's idle, it can immediately start continuing with your test. So I'll run that one more time so you can kind of see. Test starts executing, gets to a .check, Espresso gets in there, holds up your main thread at the beginning and starts looking at the messages, looking for those conditions to be met. And then eventually it returns control to the test thread so your test can continue on. So this kind of loop main thread approach is also used in another framework for iOS called Earl Grey. So if you do iOS testing as well, or you have colleagues who do iOS testing, you can look into that. And it has kind of some of the same properties about being fast and reliable. If you want to see kind of how that works on iOS, you can look at the Grey run loop spinner that's on that repo. That's also a framework from Google. All right, so now we've looped the main thread. We think that everything is idle. So the app's just sitting there now waiting for us to either inspect, and we're doing a check, so we're just inspecting the state of the view hierarchy, or you could do a perform if that's what you're calling. So now it needs to find the actual view, see if this view that we're trying to check is actually even there. So remember, viewfinder was something that gets instantiated every time you call on view, and the viewfinder wraps your view matcher. So it's going to call viewfinder.getView. So let's look at what getView does. So getView is going to have three possible outcomes. It either just returns a view, hey, I found one view, here's the view. Or it found more than one view, and it's going to throw an ambiguous view matcher exception. That means it looped through all your views and it found more than one, and so it's ambiguous, it didn't know which view to return because it only is going to return one. Or it didn't find any views that match, and it's going to throw a no matching view exception, which depending on the type of view assertion that you passed in, actually may be a successful condition. So the first thing it has to do is it has to figure out which view hierarchy is it looking into. So every activity has its own window. Every window has its own view hierarchy. So there's a root view with a whole tree of views for every activity. So if you have two activities and one comes in front of the next, Espresso needs to make sure it's looking at the activity that's in the foreground that has focus. Similarly with dialogues have their own view hierarchy because they have their own window. So if you want to look at something in a dialogue, Espresso needs to be smart enough to grab that view hierarchy to look for the view in if the dialogue is in focus. Also similarly for like a spinner with a dropdown, that dropdown menu that's hovering above your application is also its separate window with a separate view hierarchy. So if you're looking for something in a dropdown, Espresso has to make sure to look at that view hierarchy. So if you're getting a weird message or you're getting a weird test failure, usually it prints the view hierarchy. It says, I can't find a view, here's the view hierarchy. If the view hierarchy looks like it's for your activity where you're expecting your view hierarchy to be for your dialogue because you were looking at something in a dialog box, then something is going off and this root viewfinder or view provider is not somehow finding the right view hierarchy that it needs to be looking in. So we get the root view. And then we do a breadth first view traversal of the root view. And we pass that, and so that's just a list of all the views in the hierarchy. We pass that into the filter method, and we also pass in the matcher, which is the with ID Bible search, remember, from the beginning. And then we just iterate over all the views after we've filtered for only the views that where the matches safely method returns true. And then we return in one of the three conditions. Basically, if we go loop through that and it sees, okay, we found one and then we find another, it throws the ambiguous view matcher exception. If we get through the whole thing and the matched view is still null, that means we didn't find anything, it throws the no matching view exception. Otherwise, we got one view, and that's what we were looking for, and we return that view. All right, so now we have this view assert, which I'll talk about in a minute, and we're going to call check on that. And we pass in two things. We either pass the view or we pass the missing view exception, which we caught above. So we don't catch the ambiguous view matcher exception. That just causes your test to fail. But you'll notice here, it catches the view missing exception. It passes that into the view assertion. And if you remember from the high-level statement, the view assertion, which we'll talk about in a minute, is the matches is displayed, is the view assertion here. So the reason why you would want to pass in the missing view exception, and when the missing view exception is passed in, the view is null, is for to allow things like you want to check that the view does not exist. So if you're saying this view does not exist, this text is not displayed, things like that, you need to be able to handle the case where the view is not there. And so your assertion would return, it would just not fail when the view is null and you got that missing view exception. So that allows that use case of when the success case and what you're actually asserting is that the view is totally absent. So the view assert in this case is the result of matches, and we passed in the is displayed into matches. So what does matches do? Well, matches takes a view matcher and turns it into a view assertion. So check needs a view assertion, and we have a view matcher, which is displayed. So we have to do this conversion from view matcher to view assertion. A view assertion is the thing we just talked about, which takes a view and a no matching view exception, and it just returns normally and does nothing if it's successful. Otherwise, kind of like a fail statement or an assert statement in your test, it throws an assertion error on the case where the check fails. So it either throws an error or it just returns normally and does nothing. So it uses that matcher. In this case, we'll see in just a minute, the matcher in this case is displayed. If it matches the view, then it's fine, you just return, nothing happened. Otherwise, if it didn't match the view, you're gonna get a nice human readable message, and then you're gonna fail the test with an assertion failed error. So this is how you convert a matcher of view to a view assertion, which is what is needed for what is needed for a check, a call to check. Now, you can also implement, you'll notice this implements, this is a view assertion. So view assertion is just an interface that you can implement yourself. So if you need to do custom introspection on the views to look for specific things, you can implement a custom view assertion and just pass that into check. So is displayed is the view matcher that we just converted to a view assertion. So let's look at what is displayed does. Creates a custom internal class called is displayed matcher. And the displayed matcher, again, it extends the type safe matcher, but it basically takes in a view, and it's going to look at the view in two different ways to see if it is displayed. It calls get global visible rect on the view, and all this does is look if the view coordinates are within the bounds of the screen. So if your view is just like your x coordinate is way off the screen, obviously it's not displayed because it's not even on the screen. So this is just checking, is the view within the bounds of the screen? It returns true if it is, false if it's not. So it may be within the coordinates of the screen, but it also has to be visible. If it's displayed, it needs to be visible to the user. Well, you can't just check visibility on the view itself, because if its parent's invisible, it's not going to be displayed, or if its grandparent's invisible, it's not going to be displayed. So you have to call this method with effective visibility, and it's actually delegating to another matcher here. But this matcher looks at the view. Is the view visible? Okay, the view's visible. Well, check its grandparent and go up the tree looking at the view parent and the view parent of that view parent, and just make sure all the way up the view hierarchy it's visible. So now it's within the bounds of the screen. It's visible. All its parents and grandparents are visible. So we're ready to say, yep, is displayed. So we made it. We dug down deep into the internals of Espresso and back up, and that's how this basic Espresso assertion works. So we're going to look at one more thing today, and it's not directly tied to Espresso. It's actually part of the test runner rules library, which is also part of the Android test support library. So we're going to look at how you launch an activity within your test, which is also a common thing where people run into errors. So it's good to know how this works. Because if you think about it in your app, you just call start activity and it's asynchronous, and later the activity starts, hopefully fairly soon. But in your test, you want to not execute the next line until your activity is actually resumed. So it needs to be synchronous, whereas the general activity starting is not synchronous. So let's say we wrap our Bible activity in an activity test rule, and we say we want to launch that activity. So what is that doing internally? Well, inside of activity test rule, which is a class provided by the rules dependency from an Android test support library, it calls instrumentation.start async, or start sync, sorry. Start activity sync. The instrumentation is almost like a equivalent of the application in your app, but in your test you have an instrumentation, which is kind of like this one per process object that manages the overall lifecycle of your test. It's actually, the instrumentation is also your test runner. So it's calling into instrumentation, and it's calling start activity sync, so let's see what that does. So normally, what start activity sync does in the framework version of instrumentation is it goes and starts that activity and waits for it to be resumed, and if it's never resumed, start activity sync never returns. So your test could just hang forever, which is not great. You would like the timeout at some point. So what monitoring instrumentation does, which is the version of instrumentation that comes with the test runner that is part of the Android test support library, is it basically pushes off the framework version of start activity sync into a background thread, and then it gets a future from that executor, and it just calls a get with a timeout, so that if the framework version never returns, it can just time out itself and throw an exception saying, I couldn't launch this intent. I think it waits 45 seconds by default, and so then it fails your test, and you don't just wait forever, which would be bad. All right, so what does that start activity sync? So this is the framework version. What does that do? Well, it calls the normal start activity. And you notice get target context here. That's important. There's two versions on the instrumentation. There's get target context and there's get context. And the difference between the two is get target context gets the context that gives you access to the resources and the things included in your app APK. Whereas if you call just get context here, that context is pointing to your test APK. So it's looking for activities and things and resources if you have them inside of your test APK. So since generally your activity is part of your app APK, you want the target context. And we're calling this start activity here. Now this start activity is asynchronous. It returns immediately, goes off to the activity manager, and it goes through the life cycle of create on resume. So we need to add the synchronous part here. And what that does is there is this a monitor where it calls wait on that monitor. And so it just waits there until notify all gets called. And that gets called in a callback called it's just called pre-perform create. And this is right before the activity is actually created. It calls notify, which allows us to continue past the wait. And then that's in a while loop because wait could actually be triggered by other things. So it actually has a list of the wait activities it's waiting for, and it makes sure that that specific AW or activity waiter was removed. And that activity waiter also gets removed when it calls pre-perform create. And then it comes down at the end, and because this not only needs to start the activity, the general start activity method doesn't return a reference to the activity. So we need to get a reference to the activity. So when it's almost about to be created, we capture a reference to the activity and put that in the activity waiter so that we can then return aw.activity. And that gets set in the pre-perform create method. So we have a reference to the activity. Well, the activity that we have at this point has just been after pre-perform create. So we want to wait until it's at least resumed. So because the test runner doesn't depend on Espresso, we can't use the Espresso loop and idling mechanism. So we use this one that's built into instrumentation called wait for idle sync. It has some issues where it's not quite as smart as the Espresso version, but because we don't depend on Espresso, it's kind of the best we get here. And this will just wait until it uses a, basically it will wait till there's no messages in there, but it's not checking for conditions, it's not checking for idling resources, so it's certainly not as smart as exactly waiting for what's going on in your app. But it's good enough to get you to the on resume and make sure the on resume has been processed on the main thread. And then we call embase.evaluate, which is actually your test code. So it launches the activity right before your test runs. And then you can call your Espresso checks and your Espresso performs after the activity has been launched. And that's all I have for today. Thanks.